Hey y'all, it's me, Miss B. Today we are going to continue understanding the basics and performing row operations with more um, of a focus on solving these things. Okay, so let's jump in. We're going to skip the warm up and jump into our real life example. So here it says that a farm produced 3 types of eggs: large, extra large, and jumbo. And you can see that in the chart. And the number of dozens of each type of eggs sold to 2 grocery stores is represented by this matrix. So here is store 1 and here is store 2. All right, and disregarding kind of the labels on that, this right here is a matrix, and then this one down here is a matrix, and those are the prices of which they've been sold. So I have a 2. This is a 3 by 2 matrix, and this is a 1 by 3 matrix. All right, and it wants us to find BA. So what we're going to do, and this is going to show us what the total revenue is. So when we multiply together these two things, let me make it a little bigger, we're going to have this matrix. So this is money here. And these are all in dollars, by the way. And then we're going to have our next matrix, which is the 100, 60, 120, 70, 200, 120. So this one is store 1 and this one is store 2. So what we are doing is, we're going to multiply these by the first column and add them all up. So that's going to be the revenue for store 1. Then to find the revenue of store 2, we'll do all of this times these. It's a simple thing. You would be able to do it probably separately with a lot more, maybe more math, but this is a great way to do it in a matrix. That way we can use our calculators to solve it. But for now, we're going to do it by hand. So let's go ahead and do, I don't need that big of one because I'm going to end up with a 1 by 2. But we are going to label this so that we don't forget. This is store 1, this is store 2. And then we will have dollar signs on each of those as our final answer. Just kind of setting it up. So I want to do the first row by the first column and add all of those values together. So I'm doing 0.8 times 100, that's 80. 0.85 times 120, it's 102. And then 1 times 200 is 200. Okay, so there is that. Next up, we want to do our first row, our row by our second column. And that answer will go here. So we are going to do 0.8 times 60 is 48. 0.85 times 70 is 59.5. And 1 times 120 is 120. And we're adding those together. Okay, so type those in your calculators, and you should get that this store's total revenue was $382, and this store's total revenue was $227.50. So you've got store 1 and store 2. Okay, so that's a real life example there. Okay, so we're going to work through solving systems of equations. This is a pretty nifty trick here, because normally we would have to go through a lot more. But what we're going to do is we're going to set up this thing called a coefficient matrix. So remember, the coefficient is the number out front. So for this one, we are going to have a 2, and this is a 1. So 2 by 2 and a 1, 2 by 1. So our coefficient matrix is going to be 3, 2, 1, -3. So just stealing those coefficients there. The answer matrix is going to be our answers, 4 and 6. So then we're going to set up a matrix equation here. So we're going to have 3, 2, 1, -3 times x, y equals our answer equation, our answer matrix. So in order to solve, you're going to need to multiply the inverse of the coefficient matrix by the answer matrix to find the value of x and y. So if we multiply by the inverse of the coefficient matrix is going to go away. Just like you multiply a fraction, so if we had 1/4, we multiply by its inverse, 4 over 1, we get 1. So it's the same kind of concept. So let's go ahead and look through that. So here I just want to make a note about the coefficient matrix. I would write this down. So if we have a matrix C equal to A, B, C, D, the coefficient matrix, or the inverse, would end up being 1 over the AD minus BC, so those two products are crossed. And then what we do is we switch A and D, so we have D and A. And then B becomes negative and C becomes negative, but they stay where they are. And so that gives you the inverse. All right, so let's jump into this example here. We've got our matrix equation here. I'm going to go ahead and copy and paste this down here so I don't have to write it again. Okay. So we want to multiply by our matrix equation on both sides. So multiplying by our matrix equation. So our matrix, or I'm sorry, multiplying by our coefficient. So this is going to be 1 over, this is A, B, C, and D. We're going to do AD minus BC, so -9 minus 2 times 1 is 2. Over, and then for these we switch A and D, so this is going to be -3 and this will be 3. And then B and C become negative, so this is -2 and -1. We want to do the same thing on the other side. So we're actually multiplying it at the front. So this is, I'm going to go ahead and simplify, 1 over -11 times -3, -2, -1, 3. So you can see I just rewrote this right here, and we have to multiply at the front. Okay, so when we do that, this cancels because it's its inverse. We just have to multiply on the other side here. So leaving the 1/11th for now, or the negative 1/11th, this we've got xy, negative 1 over 11, and then we want to do this multiplication. So this is a 2 by 2, and this is a 2 by 1, so I should end up with a 2 by 1, which is exactly what we need in the end. Because this is a 2 by 1. So we are going to do the first row times the first column. So negative 3 times 4 is negative 12. Negative 2 times negative 6 is negative 12. Then we're going to do our second row by our first column. So negative 1 times 4 is negative 4. And then plus 3 times 6, which is 18. So that is equal to, run out of space here, that is equal to negative 1 over 11 times negative 24/14. All right, and then we'll multiply that 11 through, so this is going to be positive 24 over 11 over negative 14 over 11. It's not a super pretty answer with that fraction, but this is equal to xy. Okay, so that is how we solve that. Okay, so this next one here, I'm actually going to save for in class. I want you to go ahead and set up the equation though, before. All right, and that's it for today.